Hi, welcome back to Geometry. This is section 3.5, Parallel Lines and Triangles. We have two objectives in this lesson. We're going to use parallel lines to prove a theorem about triangles, and we're going to find measures of angles of a triangle. If you have your note template, then you'd fill it in as we go along. You can pause this video. If you don't have a note template, you could just use a piece of paper or a notebook, or you could print your own note template off of the headline page. The essential understanding of this section is the sum of the angle measures of a triangle is always the same, 180 degrees. Here we have postulate 3.2, the parallel postulate. It states, through a point not on a line, there is one and only one line parallel to the given line. So we have point P, and it does not lie on line L. So this postulate tells us that we can construct a line through point P that would be parallel to line L. So you can construct it, you can draw it. If there's a point not on a line, then you can take your pencil and draw a line through that point that would be parallel to the line that it's not on. We need this postulate for our next proof. The essential understanding of this section is this triangle angle sum theorem. The sum of the measures of the angles of a triangle is 180 degrees. So that means in a triangle there are three angles, which is why we call it triangle. The measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180 degrees. This is true of every triangle, even if it's a very small triangle or an extremely large triangle. Every triangle, the three angles that are on the interior of the triangle, have a sum of 180 degrees. We're going to prove the triangle sum theorem. This requires an auxiliary line. An auxiliary line is a line that you add to a diagram, so you draw it to help explain relationships and proofs. Here, we're going to have the proof of Theorem 311, the triangle sum theorem. We're given this triangle, triangle ABC. We are trying to prove that the measure of angle A plus measure of angle 2 plus measure of angle C is 180 degrees. So to do that, we had to add this line, PR. That's an auxiliary line. We had to add it. The parallel postulate gives you the right to do that. Because we have AC and B is not on AC, then the parallel postulate says we can construct a line that's parallel to AC that goes through point B. So that would be our first statement, that we draw line PR through B that's parallel to AC, because we use the parallel postulate. This isn't a postulate you use frequently, but we're going to use it now to prove the triangle angle sum theorem. We're going to prove all three angles of a triangle equal 180 degrees. So that means that P, B, C, and angle 3 are supplementary. So PBC is this angle, plus angle 3 are supplementary, because they're a linear pair. And therefore, using the linear pair postulate, they're supplementary. That means we know the measure of angle PBC plus the measure of angle 3 is 180. PBC plus angle 3 equals 180, because that's the definition of the word supplementary. The measure of PBC is equal to the measure of angle 1 plus the measure of angle 2. That's using the angle addition postulate. We added two angles together to get this larger angle, PBC. The measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. That's using substitution, because PBC plus 3 equaled 180, and PBC equals 1 and 2. We can take 1 and 2 and put them in the place of PBC. So 1 plus 2 plus 3 equals 180. So we use substitution. We combine steps 3 and 4. we know that angle 1 is congruent to angle A. Because remember, back up here in this step we said line PR and AC were parallel. So angle 1 is congruent to angle A, and angle 3 is congruent to angle C, because they're alternate interior angles. So using the alternate interior angle theorem, that's what this states. If lines are parallel, then the alternate interior angles are congruent. We know that the measure of angle 1 equals the measure of angle A, and the measure of angle 3 equals the measure of angle C. Because they were congruent, that means that they are equal. Definition of congruent. Congruent angles have the same measure, equal measure. And because we know A is 1 and C is 3, we can take 1 out and put A in its place. We can take 3 out and put C in its place. So therefore, the measure of angle A plus the measure of angle 2 plus the measure of angle C equals 180 using the substitution property. And in this triangle, we knew that A was congruent to 1 and C was congruent to 3. And if 1 plus 2 plus 3 equals 180, then we know that A plus B plus C equals 180. So we just proved the triangle angle sum theorem using parallel lines. Alternate interior angles are congruent because we constructed this line, PR, that was parallel to this line, AC, and the sides of the triangles acted as transversals. We can prove the triangle angle sum theorem. Let's use the triangle angle sum theorem. What are the values of x and y in the diagram at the right? To begin this problem, let's take a look at this smaller triangle, triangle ABD. We know the measure of angle A is 59 degrees. We know the measure of angle B is 43 degrees. We know that all three angles of this triangle equal 180 degrees. So we could set up an equation to solve for the value of x. So your equation would look like this. 59 plus 43 plus x is equal to 180. We'd combine like terms to get 102 plus x is equal to 180. We'd use the subtraction property to isolate the variable. So x is equal to 78 degrees. So now we've solved for x. Now let's move on to z. Angle Z is the third angle of this larger triangle, ABC. Angle A is 59 degrees. Angle B are both of these angles put together, 43 and 49, and then angle Z. So set up a similar equation to the one we just used to solve for the value of Z. So in this larger triangle, we know angle A plus angle B plus angle C is equal to the whole triangle, triangle ABC. A is 59, B are these two angles together, so it's 92 degrees, and C, oh, that we don't know that. That's Z. Is equal to 180. So that means 151 plus Z equals 180. When I subtract 151 from both sides, Z is equal to 29 degrees. So now that we know Z, can we find Y? Can you set up an equation for that? Take a look, see if you can figure out what triangle Z and Y both belong to. So triangle BCD is made of these three angles. B is 49 degrees, C is 29 degrees, but we don't know D, so it's represented by Y. Write an equation so you could solve for Y. So if you wrote an equation, 49 plus 29 plus Y equals 180, You combine like terms to get 78 plus y equals 180. Use the subtraction property to find that y is 102. If you might remember earlier, we said that x was 78. X and y are a linear pair. That's right. So x and y together equal 180 because they're a linear pair. So you could have used a linear pair postulate there also. The next thing we're going to talk about is an exterior angle of a polygon. It's an angle formed by a side and an extension of an adjacent side. For each exterior angle of a triangle, the two non-adjacent interior angles are its remote interior angles. In each triangle below, angle 1 is the exterior angle, and angle 2 and 3 are its remote interior angles. So angle 1 is formed by an extension of the side of the triangle, and you'll notice 2 and 3 are the ones that are not touching angle 1. This one is its adjacent angle. 2 and 3 are non-adjacent interior angles of the triangle, so they're called remote interior angles. Same here, angle 1, this is the exterior angle. It's on the outside. The one that's right next to it is its adjacent angle. And yeah, they form a linear pair, so it's 180. 2 and 3 are the remote interior angles. They're non-adjacent. And the same thing here, if we tip this triangle over, angle 1 is the exterior angle. The angle that's adjacent to it is its linear pair. Together they form 180. And therefore, 2 and 3 are the remote interior angles. They are non-adjacent. So you might guess that this is where our next theorem is going to come from. Because angle 1 and the one that's right next to it together equal 180, then this is where our next theorem stems from. This one's called the triangle exterior angle theorem. The measure of each exterior angle of a triangle, so angle 1, that's the exterior angle, here, angle 1, is equal to the sum, so these two added together, of the two remote interior angles, of these added together. So the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. And let's find out why. So, if angle 1, let's call this one x. If angle 1 plus x equals 180, because they're a linear pair, and you know that angle 2 and angle 3 plus angle x are equal to 180, then you must know that 1 and 2 and 3 have the same value, because when I add them to the same thing, they have the same sum. So angle 1 must equal the same measure as 2 and 3. And that's the idea of this theorem. So the exterior angle, the one on the outside, equals the sum of these two on the inside. Let's use that. So using the triangle exterior angle theorem, let's find the measure of angle 1. Angle 1, the exterior angle, is equal to the sum of the two non-adjacent interior angles. So in this case, the measure of angle 1 would equal 80 plus 18. So the measure of angle 1 is going to be 98 degrees. The exterior angle theorem says that the exterior angle of any triangle is equal to the sum of the two non-adjacent interior angles. So not the one that's right next door, but the two that are not next to it. Them added together equals the one on the outside. You try this one. What do you think? If the exterior angle is equal to the sum of the two non-adjacent interior angles, then how can we find one of those non-adjacent interior angles? We would write an equation. 124, which is the exterior angle, degrees is equal to the sum of the two angles on the non-adjacent interior. So 59 plus x. You would use your subtraction property here and say 124 minus 59 to get that this interior angle, the measure of angle 2, is equal to 65 degrees because 124 is equal to 59 plus 65. We're going to put these theorems into practice some more tomorrow in class. And then we're going to wrap up the chapter this week. And we're going to have our Chapter 3 test on Friday. If anybody's interested in staying for extra help, I'll be around Monday after school. Have a great rest of your night. See you tomorrow.